Okay, so hello everyone. My last exam is on 16th May and it's currently 11 p.m. of 12th May. I am practically forcing myself to study right now, and that's why I'm recording this video. I will read the lecture slides. This is the first chapter, and yeah, I'll just give an explanation of what I just learned, and then after recording the entire video, I will probably watch it again the day before exams so that I can just recall what I just learned. Yeah. Anyways, so at the beginning, let's see the terms we have to familiarize ourselves with. So projectile is an wait. A projectile is an object thrown into air or space, such as a baseball, rock, satellite. Okay. The term artillery refers to projectile weapons, for example, cannons, guns, or rockets with guiding. Wait, okay. So artillery refers to projectile weapons. This is the key word. And ballistics refer to the study of motion of the projectiles. A missile is an artillery piece having a propulsion system. Okay, so something that you can change during its motion. Examples of artillery without propulsion are guns, cannons, okay, siege machines, catapults. Because you can't change the direction, the pathway the of the projectile. Cannons first appeared in the 12th century and were used extensively during the 18th century and the 19th centuries. Cannons can be found on land, ships, and fortresses. A cannon uses gunpowder as its propellant. Okay, the explosion of gunpowder expands. The explosion of gunpowder expands the air inside the bore, which creates an enormous pressure. Okay, so here, let me just try to visualize this. So gunpowder is somewhere on. I think there was a, yeah, here it is. I guess the professor explains it later. Okay, these are some examples of cannons. Anyways, okay, so I don't think I need to memorize all these. Let me just take a look at the diagram. So the main thing that I have to know is this is the place where we store gunpowder, and then above that there must be a space, right? Because oh wait, yeah, there has to be some space because air is basically expanding, and so it needs some space at least at the beginning. But anyways, and then the cannonball, and this entire thing is the bore. Okay, got it. The pressure creates a force that pushes the cannonball out of the barrel. So basically, when we ignite the, what was this? Ignite the gunpowder. Yeah, when we ignite the gunpowder, it explodes, and the air or whatever gas molecules that are present, they expand. And since there isn't any space here, the gas molecules are expanding right now, and therefore they will push the cannonball outwards. Okay. A cannonball has no propulsion system, yeah. Therefore, the explosion of gunpowder is the only propulsive force. So basically, the initial force is the only force that makes the cannonball move outwards. Here is a typical procedure to shoot a cannonball. Okay, put out any burning embers inside the bore left from the last shot. Okay, what does this mean? Put out any burning embers inside. Burning embers, what the fuck does ember mean? Okay, so this basically means that after firing a cannonball at, we have before shooting the next cannonball, we have to basically clean the entire bore, uh, so that there isn't any ignition. Or else if we try to insert gunpowder again inside this, the gunpowder will explode, right? And anyone who is putting the gunpowder inside will be in harm. So that, yeah, there's that. Gunpowder is inserted, yeah. Then the cannonball is inserted, the gunpowder is ignited and explodes inside the bore. Okay. How fast can a cannonball go? The contribution of Benjamin Robbins. I don't think we have to remember these facts. Okay, Benjamin's work on ballistics was published in 1742. Which one? I don't know. In which he set out a series of propositions forming an early model of physics of guns. Here's the summary of his findings, okay? The explosion of gunpowder converts the powder to a gas. Okay, this seems pretty obvious. The explosion converts the powder to a gas, okay? The volume of gas produced is proportional to the quantity of powder. Yeah, this is also obvious. So like the more powder you have, the more gas will be produced after the explosion. Robbins determined by the experiment that one ounce, okay, at something grams of gunpowder produces this much inches cube, I guess. Okay, okay, so a certain amount of gunpowder produces a certain amount of volume of gas at RTP. The gas produced is permanent, not diminishing in volume over time. Okay, so the gas that is produced after the explosion uh, has a fixed volume and it does not decrease over time. Okay, this is a important fact, I think. Okay, the high pressure in the bore is caused by two effects: the large volume, okay, and the high temperature. Okay, so I remember this formula. I think PV is equals to NKT. I think I learned it in physics A levels. It was 3 years ago. I don't know if this is the exact formula or not, but let me just check. The pressure is high because volume. I'm just wasting my time at this point. Anyways, this creates a force pushing the cannonball out of the bore. Okay. Okay. This formula. The force with which the cannonball is fired outwards is given by this formula, and I don't know the terms. What is R? Okay, it's given here. R is the initial ratio of hot gas pressure to atmospheric pressure. Ratio of pressure divided by atmospheric pressure. Okay, so basically R is P divided by P ATM, and the next term is P ATM. Then they basically cancel each other out. Then we are left with just the pressure of the gas. I guess the pressure of the gas is not easy to find out directly. That's why but somehow we can get to know the ratio. I guess that's why the formula uses R. Okay, anyways, what's A? A is the sorry, A is the cross-sectional area of the bore. So I think this area is A. Okay. What's C? C is the length of the bore occupied by the powder charge before. Oh, okay. So basically, this length, this particular length is C, the chamber length, basically. Okay, got it. The force is, but I think I have to memorize this formula, unfortunately. Okay, then we just highlight this. So F is equals to RPT P. Okay, anyways, what's X? X is the distance the ball has moved down the bore. with x equals to 0 corresponding to the resting position of the cannonball. All right, so x is from this edge to, I guess, this part or this part, I'm not really sure. X equals to 0 is corresponding to the resting interval. Okay, anyways, the force is converted to a kinetic energy of the ball and thereby increases its velocity. If we neglect the friction between the ball and the board, the velocity is this. Okay. Okay, so we have to memorize this formula as well, and this is annoying. Is there any way I can derive this formula? So this is the force. This is the force. We don't know. This is the area. Okay, let me just try. This is A. And what is M? M is the mass of the ball. Okay. Okay. I don't know how they introduce L in here. Length of the ball. Oh, okay. So basically the ball travels the length L, right? Okay, let me just try to derive this formula on my own. Right. So the work done is for integral of fx with respect to the distance traveled, right? So integrating this, the all the quantities above are constants times ln x. Okay, equals half mv square, and I need to make v the subject, so 2 by m. Okay, this part is exactly the same, and a is basically this, because we can clearly see that the cross-sectional area of the bore is basically the area of a circle, which is pi r square, and if we try to write the formula in terms of diameter, we can write pi d by 2 square, which is basically pi d square by 4 c. And then the only difference is in this part. My one is ln x, and the given formula is ln L by C. Okay, so now the question is, what's the difference between L and X? L is the length of the bore, and X is the distance the ball has moved down the bore with X. Okay, why am I doing these? Like, I can just memorize the given formula. Anyways. This formula is derived from the assumption that all the energy, this is an important fact. This formula is derived from the assumption that all the energy or work done that causes the ball to move is perfectly transferred into the ball's kinetic energy. Okay. Oh, I think the derivation is given here. Let me just check. Oh, yeah. So half mv squared. Oh, so basically the values L and C, the quantities L and C come from the limits, and I forgot to include the limits. Makes sense. Yeah, the limits are C to L because X is basically like X0. X0 is basically, let me just try to make myself understand this. this is x0, and this is basically the maximum x, right? So the limits of the integral should have been 0 to x, right, in terms of x. But if we convert the limits in terms of c and l, like this length, this is the length of the, sorry, wait, yeah, this is the length of the bore, right? Oh wait, no, I am contradicting myself. Anyways, I don't need that, but anyways, so we now calculate the muzzle velocity from for an 18th century cannon. Pressure this. Okay, this is just an example, work example. C is, oh, we just have to input the values in the given equation. I have to memorize this. Okay. The next is Mythbusters. Real cannon versus leather cannon. Okay. Muzzle velocity of real cannon was 389 miles per hour, which is around something something. Muzzle velocity of leather cannon was significantly lower. Okay, which is around. The reduction of muzzle velocity was probably due to delamination of barrel and deformation of the combustion chamber. Okay, the reduction was basically delamination of the barrel. Let me just ask GPT. Reduction of muzzle velocity was to delamination of the barrel and deformation of the combustion chamber. Explain. Um, why was it okay, so delamination means the layers of the barrel material are separating. Cannons or guns are often made with layered material or reinforced material. If the layers come apart, it weakens the barrel. It lets basically the uh, this entire structure is weak, or the layers are basically coming apart, and hence the gases are escaping, making this cannon less efficient. Okay, and the deformation of the combustion chamber is where the gunpowder ignites and generates pressure to push the projectile. If this chamber, the entire chamber is deformed, okay, the burn pattern of the powder changes the chamber. Okay, so basically, if the cannon is made out of leather, then the cannon structure changes when we are shooting a cannonball, and that's why the entire thing is not that efficient. That's the summary, I guess. Since air pressure inside the bore dropped significantly, the muzzle okay, since air pressure, yeah, so delamination and deformation, um, these two factors actually make the air escape from the cannon, and that's why the air pressure inside the bore reduce. Okay, so yeah, so if the air pressure decreases, then R decreases, right? Because R is basically the actual air pressure divided by PATM, and if P decreases, then the entire thing decreases. Okay. How far can a cannonball go? In the previous slide, we calculated the muzzle velocity of a cannonball for an 18th century cannon. Now we are going to find out how far it can go for a given launch angle. This is called external ballistic problem. Okay, okay. So now I guess this is projectile motion. Anyways, so on a flat ground, if we launch at a certain angle, then these are some trajectories. Here are our assumptions: no external force during the flight, except the downward force by gravity. Okay, so there aren't any external force apart from gravity and the initial force. But this force is not continuous, it is just given at the beginning of the motion, so we don't count that. No aerodynamic drag, so no air resistance during the flight, so that the weight is okay. Under these assumptions, the size and shape of a ballistic object do not affect its path. This is not true if we take the air drag into account. A cannonball has a much larger drag than a bullet from a handgun. Of course, the volume is much higher, so the air resistance is much greater. In the following, Vt is the velocity of a cannonball over time. The muzzle velocity of the cannonball is V naught. Wait, muzzle velocity. Okay, got it. So by muzzle velocity, they mean the initial velocity. Okay, let G equals 9.81. Okay, what is this? Oh, so these are the components. This is the vertical component, this is the horizontal component. I personally prefer x and y, or vy and vx. Anyways, we know I don't need these. Okay, and then the cannonball attains the highest point. H is equals to this. Do I have to memorize these formulas? That's the question. Because I know that I can derive these. I think I can. Let me just try. Like, this is the height of the maximum height. So basically, this, right? This is H, and we know that. Let me just derive it. So the initial velocity is v naught. So uy is equals to v naught, and then at the maximum height, the final velocity vy is equals to 0. This is a known fact because this is the turning point, and acceleration is minus g, and what else? We need to find h. Okay, so I need to use the formula v square is equals to u square. No, not that one. V is equals to u. Yeah, v square is equals to u square plus 2as. And so 0 square is equals to v naught square plus 2 times minus g times h. This is what I'm trying to find. So h is equal to v square divided by 2g. Yep. And the time. Okay, so the time is t is v is equals to u plus at. 0 is equals to v naught minus gt. So t is equals to v naught divided by g. Okay, so the two formulas are derived. The cannonball impacts the ground when t is equals to 2 times. Okay, so the time it takes to travel from the initial point to the maximum point is this time. So the time to travel from the maximum point to the ground is exactly the same. So the total time is twice of this. Okay, so this formula is also derived. Next, the range d for a particular angle theta is the distance traveled horizontally for a time duration. Okay, so the range is a horizontal distance traveled. Range is the horizontal distance traveled, and we know that there is no force or no acceleration in the horizontal direction. So ux is equal to v naught sine or cos. Wait, the angle is with angle is cos, sorry, not cos theta, and we are required to find the range. So distance is basically speed times time. So speed is v naught cos theta, and the time is wait, am I missing something? The range is travel. This is the time, right? No, the time is twice of that. Okay. What am I missing? What am I missing? Let me just recheck. So I'm resolving horizontally. The initial velocity is v naught cos theta, and the total time to travel from the initial point to the final point is 2 times v naught divided by g. Acceleration is 0, and I need to find the distance. Okay, so v square, wait, s equals to ut plus half at square. Yes, s is equals to ut plus half at square. Okay, s is d, u is this, half times 0 times d square. So this entire thing becomes 0. So distance times time is 2v naught divided by g. Is this wrong? Okay. Two v squared sine. So what I am missing right now is the sine theta. And why am I missing that right now? That's the question. Oh, yep, got it. So here is the issue. This should be, u naught should be v naught sine theta. So v naught sine theta square. This should be v naught sine theta, the entire thing square. And this should be v naught sine theta. So this entire thing is multiplied by sine theta. This is also multiplied by sine theta. So finally, the result is 2v naught square times sine times cos divided by g, and we know that 2 sine theta cos theta is basically sine 2 theta. So sine 2 theta divided by g. Okay, got it. Now I think I should memorize the equations because deriving them is quite time consuming. And the maximum range is when theta is equals to 45, since okay, this is obvious. Previously we have calculated that the muzzle velocity of a 18th century cannonball is this. Okay, we will calculate how far such a ball can fly before hitting a target on the ground. Assume that theta is 10 degrees and distance. We can just use the equations that we just derived. A cannonball elevated at an angle this is fired at a castle 400 meters apart. The castle is at the ground level as shown in the following figure. The muzzle velocity of the cannonball is 100 meter. Okay, so the initial velocity is 100 meters per second. Air resistance is neglected. What's the range? So we are required to find the range, meaning this particular distance, or what? Yeah. So what is the maximum distance that the ball can travel at with using these quantities? So I can just use the equation of range. Let me try to recall it from memory. It was v naught square times sine 2 theta divided by g. Um, yes, lucky. And then can the, so if the distance is greater than 400, then yes, what should the angle, so that means b is, it does not hit the castle anyways. So we for this we just have to rearrange and subject, make theta the subject of the equation, I guess. Like d should be 400, this is the given target, so v naught square times sine 2 theta, so make theta the subject of this equation, that's it. So these are the solutions. Yeah, got it. The top of Edinburgh Castle is 80 meters higher than the land surrounding it. So, okay. You fire at a particular position which is d meters away from the castle horizontally. So the distance from horizontally is d meters. This distance is d. Let theta be the elevation angle of your cannon. Choose a combination of d and theta such that the cannonball hits the castle top when it achieves its greatest vertical height. Okay, so our target is when the ball, so here's the trajectory of the entire projectile, right? So when the maximum height is yeah, when the ball reaches, our cannonball reaches its maximum height, it should hit the castle. That's the target. So this should be the be like, yeah, this should be the maximum point of our cannonball. That's the target. And we need to find the combination of the range and the angle theta. In fact, theta is the smallest elevation angle. Okay, so the first states that the maximum height achievable should be 80 meters. Second states that d should be half of its range. What does this mean? I don't understand this. The second states that d should be half of its range. What? When did they say that? Such that. They did not mention that in the question, but anyways. Carried by 2g, so half. Okay, anyways. This seems fairly easy. So to show the statement theta is the smallest elevation angle, one can use to hit the top, we consider the following figure. The path in red corresponds to the angle theta and distance d we have obtained previously. Okay. We can see that that any angle smaller than this cannot reach the castle top, but this is made through computer simulation, right? I won't have this during my exam, regardless of the cannonball's distance from the castle. This is because a smaller elevation angle leads to its lower vertical velocity. Okay. Uneven ground. On uneven ground, the range for a particular theta. There are so many weird equations that I have to memorize. This is annoying. Okay. So this part is consistent with the previous part, and this part is extra, and I don't think I know how to derive this. Or do I know? Even if I know the derivation, I don't think I should think about it right now, because it's really annoying and it's gonna be time consuming. When h naught is 0, so when the ground is even, the range is the same as that we obtain. Okay, yeah, got it. The maximum range is a bit complicated, so we skip it here. Okay. Anyways, so the professor did not explicitly show any calculations from this one. Do I have to memorize this? I don't want to memorize this. Let me just see if there is any pattern or not. Half, where does half come from? Anyways, missiles. Okay, so missiles are guided or unguided self-propelled weapons. Common type air to. Okay, there are certain types of missiles. The term ballistic missile refers to a class of large caliber self-propelled partially guided or unguided projectiles that follow a ballistic trajectory for most of their flight path under the influence of gravity. Ballistic projectile or payload is typically propelled into motion by a single and limited duration energy transfer event, such as an exploding artillery round or ignited rocket motor. Okay. Once the energy transfer event is complete, the projectile will have reached its maximum velocity and its momentum carries it to follow a ballistic trajectory that is mainly shaped by the effects of gravity and to a lesser degree by other influences such as air friction. Ballistic missiles are most often categorized as lack of universally accepted standard, though. Wait. Ballistic missiles are most often categorized as. Okay, so this is unnecessary. As short range, medium range, and intermediate range. So, do I have to memorize the ranges? I don't think so. Short range, medium. I don't think I do have. Okay, anyways. Cruise missiles are guided with high precision, which can be launched from a ship, submarine, or jet fighter. Okay, so these are just some random facts about missiles. I don't think the professor will ask questions based on that. This is something I need to know. The 1/2 rule. I remember the professor was telling us that this is important during the class. In section 8 of Physics of Space Security, the author suggests a 1/2 rule for calculating the range of an intercontinental ballistic missile. A useful rule of thumb is that a ballistic missile that can launch a given payload to a maximum range r on Earth on the Earth can launch that same payload vertically to an altitude of roughly r by 2. Wait, let me just reread. Then maximum range r on a maximum range r on the Earth can launch that same payload. Okay, so the maximum range horizontally, if this is r, then the maximum height, vertical height of that exact same missile is r by 2. I think that's what this statement is saying. This relation is exact in the case of flat Earth and therefore holds for missiles with ranges of up to a couple thousand kilometers. Okay. The Earth appears essentially flat over large distances, okay, which is small compared to the radius of Earth, but the rule continues to hold approximately for even intercontinental range missiles. Okay. The estimation is based on an assumption that Earth's curvature can be neglected and that air resistance. Okay, so this is an important fact. So the estimation, the statement is that if uh, r is r, the range is r, then max height, the maximum height is r by 2 and vice versa. Okay. If and this statement assumes that the Earth is flat for a certain distance and also the air resistance is negligible. We could ignore the rotational motion of Earth, and the model for a missile is approximately the same as the model of cannons we have seen before. The longest horizontal distance is achieved by launching at angle 45. Okay, so highest altitude is okay. So basically, this is the general derivation of the the statement. Okay, so the maximum distance is v square by g. Highest altitude is given by this formula, and if it was launched vertically, then sine 90 is 1. Therefore we can just write w square is equals to v square. Okay, got it. So for really large distances, the rule is not that reliable. Okay. So these are some random facts about missiles, I guess. On May 14th, 2017, the Nord's official KCNA news agency said the ballistic missile named was something was launched on an unusually high trajectory to avoid threatening the security of nearby countries. Okay. North Korea. These are some random facts that I don't need to know. How long has it been? So 43 minutes. That's the most amount of studying that I did in the last, I don't know, 2 weeks or so.